Hello students, in this video lecture we will discuss second order differential equation by using Laplace transform presented by Dr. R. Dinesh Babu. So now using Laplace transform we are going to solve second order non-homogeneous differential equation along with the two initial conditions. One is y of 0 equal to 0, another one is y dash of 0 equal to 0. One second order non-homogeneous differential equation is given. Okay, so now we apply Laplace transform on both sides in this equation. We get L of y double dash of t minus 3 y dash of t plus 2 y of t equal to L of e power minus t. So now using linearity property for Laplace transform, so we can write this equation is L of y double dash of t minus 3 L of y of t plus 2 L of y of t equal to L of e power minus t. Also we know that L of y double dash of t is nothing but s square capital Y of s minus s y of 0 minus y dash of 0. Similarly, L of y dash of t is nothing but s capital Y of s minus y of 0, and L of y of t we can write this y of s. Also we know that what is L of e power minus at? That is nothing but 1 by s plus a. Here a value is 1, so we get 1 by s plus 1. So now substitute the given initial conditions in this equation. We get s square capital Y of s minus 0 minus 3 into s capital Y of s minus 0 plus 2 into capital Y of s equal to 1 by s plus 1. Our target is to find the capital Y of s value. So that collecting Y of s term left hand side, remaining term we should bring right hand side value. So we can write this equation is s square capital Y of s minus 3s capital Y of s plus 2 into capital Y of s equal to 1 by s plus 1. Here capital Y of s is common, so take outside from this equation. So we get capital Y of s into s square minus 3s plus 2 equal to 1 by s plus 1. So we need capital Y of s value, so you bring this term right hand side. So we get capital Y of s equal to 1 by s plus 1 s square minus 3s plus 2. Split. Now we can able to split this second order polynomial equation into s minus 1 into s minus 2. So therefore we get y of s equal to 1 by s plus 1 s minus 1 s minus 2. So we consider this is equation 1. So what is second step? So now using partial fraction method to find small y of t value. Why we are using partial fraction method? Actually, inverse Laplace transform, we have the denominator term is single factor. We know inverse Laplace transform formula. But here the denominator term is more than single factor, so that we are unable to use inverse Laplace transform directly. So that using partial fraction method, I am going to split the term. Okay. So from equation 1, we can write y of s equal to a by s plus 1 plus b by s minus 1 plus c by s minus 2. So we consider this is equation 2. In equation 2, I am going to take LCM here. If we take LCM here, we get these equations. Okay, so here the denominator term will be cancelled. Why? Because both are same. So we get the numerator value, that is equation 3. So using equation 3, I am going to find what is a value, b value, c value, which means if we substitute s equal to plus 1, we get b value, a value and c value will be 0. Next substitute s equal to minus 1, so we get a value, b value and c value will be 0. After substitute s equal to 1 in equation 3, we get 1 equal to first term becomes 0, b into 2 into minus 1 plus c value 0. Why? Because 1 minus 1 0. So now solving this equation, we get b value is minus 1 by 2. Similarly, I am going to substitute s equal to minus 1 in equation 3. We get left hand side 1. Why? Because left hand side there is no s term. Okay, so we have only constant term. So we get 1 equal to a into minus 2 into minus 3 plus b value and c value will be 0. So after simplification, we get a value is 1 by 6. Similarly, I am going to substitute s equal to 2 in equation 3. We get 1 equal to 0 plus 0 plus c into 3 into 1. So after simplification, we get c equal to 1 by 3. So now substitute a value, b value, c value in equation 2. We get y of s equal to 1 by 6 into s plus 1 minus 1 by 2 s minus 1 plus 1 by 3 s minus 2. We need y of t value, so we can write y of s equal to L of y of t equal to this term. So now we find y of t value, so that we apply inverse Laplace transform on both sides. We get y of t equal to 1 by 6 L inverse of 1 by s plus 1 minus 1 by 2 L inverse of 1 by s minus 1 plus 1 by 3 L inverse of 1 by s minus 2. We know inverse of 1 by s plus a, that is e power minus at. What is L inverse of 1 by s minus a? E power at. So here we see L inverse of 1 by s plus 1, that is nothing but e power minus t, which means a value is 1. Here L inverse of 1 by s minus a, so a value is 1. So we can write this. So we can write this y of t equal to 1 by 6 e power minus t minus 1 by 2 e power t plus 1 by 3 e power 2t. If we take LCM here, we get e power minus t minus 3 e power t plus 2 e power 2t by 6. So therefore, finally we get y of t equal to 1 by 6 into e power minus t minus 3 into e power t plus 2 into e power 2t. I hope you are enjoying this session. Thank you.